Hello coders, Synthetic Programming here with another video for you guys today. Sitting to my left is Mrs. Synthetic Programming.
Hello.
And she's going to be sitting here with me today while I teach you guys how to make plots in Python using a library called MatPlotLib. Now, graphs of data are super important for school, for work, or just for fun if you're a nerd like me. So we're going to go over the basics today of using a library called MatPlotLib, and specifically a package within it called PyPlot, and we're going to use that to make some graphs in Python straight from our code. So the first thing we have to do is import MatPlotLib. So I'm going to say from MatPlotLib. We're actually only using one library from within MatPlotLib, so we're going to say from MatPlotLib import PyPlot. Now you can get MatPlotLib on your machine by just using pip. So if you know how to use pip, it's pip install matplotlib. That'll get you the matplotlib library. And now you can import pyplot. And what we're going to do here is say as plt. So instead of typing pyplot every time we want to use it, we're going to just type plt, and that will be, it's a standard that people use when they use matplotlib. They usually import pyplot as plt, so you can just type plt instead of pyplot. So now what we're going to do is actually create our figure. So when we create our figure, we just type plt.figure, just like that. And now we're going to say fig size, just like that. And fig size is equal to a tuple, so just two brackets like that. And this is the dimensions that we want the figure to be in inches. So I'm going to use 8 inches by 6 inches. So that's the width, and that's the height. Okay. So now we have our figure. The next thing that we have to do is we have to make some data, because you can't plot nothing. You technically could, but it would just be a white screen. So the data that we're going to make starts with, we have some x values and some y values, because we're making a two-dimensional plot. So we're going to make a list called x's, and we're going to set it equal to just range 10, just like that. And range in Python returns a list of numbers. This one is going to do a list of 0 until 9. We can actually make this range 11, so it's 0 to 10, just to make it look a little bit nicer. And now we're going to do our y's like this, is equal to range, the same way, 11. Now, each of these lists, our x values and our y values, have to have the same number of data points in them. It wouldn't make sense if one of them had 12 numbers and then the other one only had 11 numbers, because the program doesn't know what to do with that last number, and it can't plot anything. So there's going to be an error. So the next thing that we're going to do is actually plot that data. And how do we do that? We can type plt.plot. It's as simple as that. And we just say x's and y's. And then finally, the last thing we're going to do for this little example is we are going to show the plot. So plt.show. And it's really easy, guys. It's as simple as that. So what we're going to do now is actually hit play on that, run it, and this is what pops up. There's going to be a graph you see here, and that graph is a line. And the line goes from 0, 0 all the way to 10, 10. And you can see that our data is plotted on this nice graph. And it pops up in this screen, and in the bottom right, there's an x value and y value number. You can't see my cursor, but as I drag it around, it changes the position down there. So I can actually drag my cursor on the screen, and I can look and see exactly what data point I'm looking at. Another nice thing is down here there's some tools. One of the tools I'll show you is zoom to rectangle. You can hit that little search bar, and now you can zoom into this rectangle, and this is what the data looks like at this rectangle. This is useful when you want to zoom into a particular point in data for a big graph, where you want to just look at a part of the graph. You can zoom in on it, and then you can just hit home to go back to the original graph. Now, that's the simplest example, but how can we make this a little more pretty, a little more complex? So the first thing we can do is add some labels. So we can add an x label. We can do plt.xLabel, just like that. And that's going to be passed a string, and that string is going to say x values, just like that. And now we can do the same thing for our y. So plt.ylabel, just like that. And then we're going to put y values. Okay. And then the last thing we'll do here is do plt.title. And our plt.title is going to be our plot with an exclamation point because we're super excited about it. Awesome. So let's run that. And when we run that, you're going to see the plot pop up. And you can see it has some new information on it. We have our title up here that says our plot at the top. On the left, it has the y values label. And on the bottom, it has the x values label. And remember, you could plot tons of different types of data. The options are infinite. So you could have the x values be the day of the year and the y values be temperature. So you could put your data on this graph and then you can label and title the graph whatever you want. So let's get rid of that. And the next thing we're going to do is make our data more interesting. So right now we have our x's as a range from 0 to 10. We're going to actually make that a range from negative 25 to 25, just like that. And now our y's, we want them to be more interesting. We want to make a function here. And so what we're going to do is we're going to make a list here. And inside the list, we want to put all of the x values, except we want to square them, because this is going to be the graph of x squared, or the plot of x squared, right? So what we're going to do is say x, and we're going to square it. So 2 asterisks is squaring in Python. So x squared for x in x's. So right now, this list is going to contain, it's going to go through our x's, and for every x value, it's going to square it and put it in this y's list. So now, when we plot this graph, you're going to see something change. The data has gotten more interesting, and so now we have a parabola. We have the graph of x squared, which is pretty cool looking compared to our silly line from before. And you can do some cool things with these plots. You can also customize what kind of points you have. So here in plt.plot, we add a string and we can say green circle. So G-O, go. The first letter is usually the color. The second letter is what you actually want the symbol to be. So if we do G-O, now we're going to get green circles. So we still have our parabola, except now it's graphed in green circles. We can actually do some other ones. We can do green triangles by doing G hat, like this. And that should, if it works, make green triangles. There we go. We got green triangles on our graph. And the last one I'll show you here, there's a bunch of them. You can look them up on MatPlotLib's documentation. GS is going to be green square. And so over here, we see we got our green squares. Now for the purposes of this video, we're just going to use a regular line. And so what we're going to do for that is G dash. And G dash is going to be our green line. It's going to look just like this. And this is because it's a continuous function. It's not just random data points that we're plotting. We want to actually show the whole function is continuous, and so we just use a green line like that. Now, why would you want to color these besides just making the graph look pretty? Well, maybe you want to put 2 functions on the same plot, and you want to compare them. And so what we can do up here is we can add some new data. We're going to make a whys2 list, and our whys2 list is going to be exactly equal to our whys1 list, or just our whys list, except this time we're going to add a minus sign in front of it. We're going to make it negative. And so now we can actually plot that on that same plt.plot line. We can say x's, because we're using the same x values, and we can do whys2 like that. And now let's use a blue line, just like that, so B dash. And so now, when we run that, look what you're going to see over here. You got 2 graphs, or 2 plots, sorry, right? 2 functions plotted on the same graph. You have this one, which is negative x squared, and then you have this one, which is positive x squared. And the reason that this is useful is because now you've color-coded the 2, you can tell between them. And you can add this information to your plot so people can see it. And the way that you do that is by under here, we have our plt x label, our y label, and our title. But what I'm going to add down here is actually a plt.legend, just like that. And in here is a list. And inside the list, we're going to say that the first line that we have is x squared. Right? Squared. Just like that. So x squared. And then the next thing we have is negative x squared. Just like that. And I just put neg because I didn't want to write out the whole negative, but you get the picture. X squared, negative x squared. So now, when I run this plot, what you're going to see is we have a legend on our graph that tells you which is which. It says that the green line is x squared, and the blue line is negative x squared. So now we've displayed two different plots, or two different functions, on the same plot. And we can compare the two and see that negative x squared is going to be facing downwards, while x squared is going to be facing upwards, just like this, which if you've taken a math class, should make a lot of sense. And then the last thing we're going to do, just for fun, is we are going to move that other graph a little bit. So what we can do here is we can say plus, and let's add 200 to it, just like that. And so now, again, this is going to be, the function is now negative x squared plus 200. So what we're going to do here is actually just say plus 200. So we've said we've got x squared and then negative x squared plus 200. We have two different functions. Play that. And now when we run the code, we see, boom. We actually have the two different functions here. We can look at their values. We can run our cursor around and use those numbers in the bottom right to see where we are. The plot legend is now down here. It says x squared is the green line, negative x squared plus 200 is the blue line, and you can compare those functions' plots. And I'll show you guys one more thing before we go, and this might be important for some of you, but the last thing we are going to do once I close this is I'm going to show you how to save this figure as an image. So what you can do is instead of plt.show, you can actually write .save fig, just like that. So save fig, which saves the figure, and you have to give it a file name, so we're going to say output.png, just like that. So now, once we run this, it's going to actually make the graph, but it's not going to show the graph like it did before. But instead, it's going to save it as output.png, and if we click on that, you may be able to see that it actually has saved our plot as a PNG image, which you can use in a school report, or you can use in a work report, or a PowerPoint presentation, or just to text to your mom because it's like the coolest thing you've done that week and she's your only friend, right? Perfect. So yeah, those are the most simple basics in using MatPlotLib to plot data in Python. Let me know what you guys think in the comments below. Please rate, comment, and subscribe if you haven't already. We're at, I think, 8,230 subscribers right now, so we're growing steadily. I'm hoping once we pass 10K, we're going to start growing even more. But yeah, I'm going to make a follow-up video to this one soon with some more MatPlotLib stuff, maybe include some bar charts, some histograms, other sort of graphs and plots that you can make in MatPlotLib, but this was just the very basics, so I hope you guys enjoyed. And if you have any questions, leave them in the comments below. I'm Ethan with Synthetic Programming, and I will see you guys in the next one. Thanks, guys.